So, good morning, everyone, and welcome to today's class. So, in the series, as I said, as in the syllabus, it was said. So, today we'll be covering something related to statistics and some basic statistics. It won't be a tedious or a lengthy class like we had previously, 2 hours and 90 minutes, somewhere around. So, this will be only a short one, some 45 to 50 minutes, and that's all. And also, next day we will be going through some of the statistics test of normality and um, p-value and t-test, z-test. So we will be covering that. But today is a very simple one, very basic, and we will go through some of its implication in how we can understand that or
Your
how it
voice
is.
is breaking.
Okay, okay then. So let us start. Uh, so something very basic that we will be covering. So statistics is all about summarizing and gathering of data. So I have a lot of data, but I want to have a summarized format of the data. That what are the insights that I can get from the data? So that is all about statistics. And the slide that I have prepared, so I will be sharing this with you, and it contains most of the details that you will be needing. Mainly the statistics purpose is not more or not much or not in detail that we use, but yeah, some of the basic things that you need to understand, because when we will be dealing with the formulas like degree of freedom and uh, p-value, t-test, so you need to understand that what these things mean and what are their implications. So for that reason we will be covering some of the basic things. So, suppose, let's say, there are two things that you need to understand. First of all, I have an entire population. So, can anyone say what is my population and what is my sample? I know it is there on the screen, but still, if you can try.
Population is superset, sample is subset.
Yeah. So population is entirely the entire data that I have. So, for example, if I'm making a survey and from that I have received some data. So my population will contain all the things that I have. And for example, if let's say I have some 10 lakh rows of data and it's not easy for me to process all of them. So there what I do is I take a sample of the data, uh, a part of the data, so that I can get a you know uh, understanding of my data, that how the entire data has been populated or has been distributed. So this is the main fund of sampling. And even sampling we have of different kinds. For example, we have a random sampling which takes sample data at a random. Then we have a stratified sampling and then a systematic sampling. So these are also a few levels of sampling, so that we can understand that from different segments of the population how my data has been distributed. So as I said, there are something like a simple random sampling, and there is certified sampling. So for that, let us say some of the code that I have. So if I need to take a sample, it would be very easy to take that. But in case if I want to make a stratified sample, then so in the last class I've discussed that for a sample the ideal code is that I take a sample and then I give my parameters that what would be my variable, let's say x, and what would be my size that I need to take from there. So depending upon that, it will take a sample. But now let us say I want to take a particular number of sample. Let's say in this thing I have, in this my variable, I have certain number of males and certain number of females, and I want that in my final data set, both should represent the same proportion as it has been represented in my population, my parent data set. So for that, what I can do is I can so depending upon the proportion, let's say if I do it like this, that uh, gender equal to here I will give male, and I know that my entire population is somewhere around uh, 70%, or let's say 100. So out of that 100, I know that few part of is my male. So here I will take 50% of the part which is there. So number of row of my parent data set with same criteria. So here what I'm doing is, so these are the number of rows with gender equal to male, and from there I'm taking 50% of the population. Okay. So this is how I can get 50% of hair, and similarly for female I can get that. And what I can do is I can then R bind both of them. So R bind data set for male, let's say X male, and then X female. So what it will help me to do is so get a sample with the same distribution as it was there in the parent distribution, parent data set. And in SAS, it is a very easier process. So there's something called survey select. So for and method here I have sample simple random sampling, or you can even give the method as stratified sampling as well. But for that there is a different code. So you can get and seed here means the sampling pattern that should be there. So even in R I can set like set dot seed some random number 1 2 3. So number here doesn't signify anything. It actually means that what would be my sampling pattern. So uh, it is a good practice to have a set seed number provided before you make a sampling. Otherwise you can, but it is always recommended to have a seed number provided before you make any sampling process. So similarly here in SAS code as well, we have this seed equal to so and so. So these are quite simple process, and code is already there. So I will be sharing you with that the code. So I think this is clear that simple random sampling would be from a sample or from a data set. If I randomly choose or pick some of the records, and that is straight away my simple random sampling. But if in case I want to uh, signify a equal proportion of distribution that was there in my parent data set and also in the sample, then it is a segmented or a stratified sampling.
Ankit, sorry to interrupt you.
Yeah,
Hello.
yeah. Tell me.
Yeah, could you please explain the concept?
So, And systematic sampling is all about fixing a rule that every seventh or fifth observation will be taken. So sampling at a certain period, or like you've just said, that at a certain interval, so it will be done. So just a minute. Now coming to this part of variable. So variable here I can have in two ways. So one is numeric and another can be categorical. So in R, when you're doing with the categorical variable, you need to specify that as dot factor. So in few of the cases I've mentioned that as dot factor works for making it a category. For example, if I have gender as male or female, so I know that it could be either of the two. So for that reason, I need to specify that it is as my factor. But in case if I have some continuous values or numbers, so which I cannot take it as a categorical, for that I need to specify as numeric. And numeric can also be of the type discrete and continuous. So these all things that you will so this is just like a digital or an analog functioning. So my clock is an example of a continuous variable which can show me time at each and every instant, but a digital clock will only show me time at a discrete level. But anyway, in R, most of the time we treat both of them as the same. Uh, but let's say my discrete would be my something similar to my as dot integer. So if I only have an integer value, it would be somewhere like my discrete. So and if I have a value like double or which can take any decimal value, then it's part of numeric continuous. So something about the outlier. So outlier can be said as the most so our value which doesn't represent my so normally what there is a difference between an outlier and a noise. So outlier, what happens is outlier is actually a part of my data set. So uh, for suppose if I have recorded some data and what I'm getting it for certain values, I'm getting some extreme values, so those are actually recorded, and that is something somewhere it has happened. But noise is something that if suppose I have a missing value or some I would say that a value which is not recorded properly or doesn't actually, or is it a false data. For let's have an example. For suppose if I go to market every day and I'm buying some groceries of 100 rupees every day, so or between a range of 50 to 150. So my normal range will be 50 to 150 range. But on a certain day, what happened is I got some extra money and I took some shopping of 1000 rupees. So that day, what will happen is that 1000 rupees will come as an outlier. Though I did that shopping, and that is not a noise. That is actually that happened. But for some reason, unknown reason, you can say that my shopping pattern was quite dissimilar to my previous pattern. So that is something called outlier. And a noise would be is that, for example, if uh, for some day I did a shopping of some 200 rupees, but instead it has been recorded as 500 or some other value, or it hasn't been recorded at all. So that will become my noise. So outlier is always you need to understand that it is part of my data set. It is part of my actual representation, but for some reason it doesn't show the trend that has been followed by my entire data. So for that reason, if I'm having a certain pattern, dissimilar pattern will actually, try to break the trend, or it would be an exception. So you need to trade those values. So actually to get a particular pattern. So let's say in this case, for all the employees that I have, most of them are having some sort of similar salaries except for one. So let me explain you in regard to the organization. So let's say if all of us are working, all of us have a experience of somewhere around 5 years, and our salaries would be at same scale. But if suppose in the same sample, if I include someone who is a senior director or a AVP of the company, then his salary would be an outlier compared to our pay structure. So that is what an outlier means. So outlier doesn't mean that it is a false or a incorrect representation of data, but actually the data is quite extreme. So in that case, if I include the salary of AVP or senior director in my population as well, then my average or the pattern of the data is expected to change. But instead, if what I do is I keep the scale only from 0 to 5 years of experience, then my pattern would more or less would remain the same. So this is where you need to spot the outlier and need to treat them. So this is one of the example that with outlier.
Ankit,
Yeah,
I have a doubt.
yeah. Tell
Uh,
me.
and which scenarios can you explain one scenario? Which scenarios we can add? I mean, we can impute the missing values and we can eliminate the outliers.
So you're saying that we need to trade the missing values and also the trade the outliers, correct?
Yeah, I mean, you are saying
Mhm.
you said right. So, like a couple of scenarios, we need to eliminate outliers. Then
Mhm.
we can impute the missing values. You told the same way. A couple of scenarios based on the scenario. First, we impute the missing values, then eliminate the outlier.
Mhm.
Yeah, which scenario we can impute and
Okay, okay.
eliminate
So yeah,
outliers?
so I will do that. So I'll explain that as well. So I have some of the same scenarios listed. So I'll be talking on them. So
Yeah, okay.
that is there in next few slides. So I think this part is understood, and you have understood that there is a difference between noise and an outlier. So outlier is part of my data, but it has an extreme value, and noise is something which doesn't actually correctly represent my data. So for noise, you need to have a good estimate to how to reduce those noise, or how to replace those noise which are a good approximate value or a good judged value. Okay, so we will see that. So Boxplot is one of the better representation of, or I can say, a better way to understand what my range is. So in previous session, we have seen a box plot. So box plot here is my interquartile range. So what it is actually my uh, 25 percentile range. This is my median or 50 percentile, and this is my 75 percentile. And this part is my IQR, starting from 25 percentile till 75 percentile interquartile range. And my maximum value that this box plot takes is 3 times of my interquartile range, starting from my 75 percentile to 25 percentile. So 3 times of this value, and if there are any values beyond this, then those are considered to be outlier. So this is one way to understand outliers, or uh, you can comprehend them. Another way is that let me draw and explain. So let's say I have a normal distribution. So normal distribution, t distribution, we will do this in next class. But for now, just understand that I have a normal distribution for which most of the values are concentrated near some main value. So here is my mean. Okay, mu. This is my mu. Now, what happened is there are some values which are more than twice of my standard deviation. So if say this is my standard deviation, so I have some values here as well. So which is way far, and these are my potential outliers which I need to treat or need to remove. So let's consider that most of the population who are traveling in a flight, they are taking a economy class, and there are few people, few high executives who are taking a ticket which is quite costly, not in a normal range, and I need to bring them to a certain level. So here what I can do is, for these outliers, I'll set a if else condition. This if else condition would be if any of my sample data which is more than twice of standard deviation, I will bring down to this level. So if any point is there beyond this point, I'll bring it down to this point. Similarly for this also, I will bring it down to here. So this is one of the way to uh, you know bring down all your outliers or change it to certain values. In this way you can treat. There are many more methods as well. Or for example, let's say what I can do is I can uh, omit all the values which are beyond this. So if I have a box plot something like this, and what I can do is I can omit all the values which are beyond a point. So beyond my maximum level, I have omitted all the points. So this is all the. So that can be done if number of these points are somewhere less than 5%, 5% or even less. That is when it is preferred. Otherwise, if you have more than that, it is always preferred to treat your outliers to a certain values. Replace it with a certain value so that it becomes part of your range. Because losing a potential amount of data could actually uh, hamper your understanding of the statistics of the data. So for that, it is recommended to replace it with a suitable value. So this was about
If
outlier.
I get one more question.
Yeah.
If we replace with other value
Mm-hmm.
with the customer has given the data,
Mm-hmm.
then it will be biased, right? The result is going to be biased, right?
Uh, no, there is a difference. There won't be that. Okay, so let me explain how it will happen.
Okay.
So let me write it in a script and explain it. So I think we have done a case for alumni donation. Okay, so here was a case. So let me just quickly run through that and explain you that how it worked. So here is my data set on donation. So for donation here I have for all the 4 years, or you can say the fifth year, 2000, starting from 2000 to 2004. So 5 years of data that I have. And let me sum up all the donation that has been provided and let me understand. So main of my total donation that has been provided so far is this 980. Okay. And let us take this sum or not sum, let's say let's do with standard deviation. So if you see here that mean is less value and standard deviation is such a high value. So my range is expected to vary a lot. So let's say if I do a box plot here and explain you of donation total given. So see, most of the people are near to zero values, and there are only few people who have donated some very high amount. So, and these are considerably my outliers, because it is very less expected from a person that he will donate such a high value. Though you are saying that it is okay that if I'm taking my outliers or making it to some other value, changing it to some other value, I might not get a particular representation, correct representation. But here is the thing that these values are quite small, quite less in number. So let's say my donation total person that I have taken into consideration is 1,230. So here I am setting a quantile. Okay. So what my quantile do? I will take a range from 0 percentile to 100 percentile, differentiate or segmented by 5 percentile. So here you see, starting from 0 to 30 percentile, nobody has made any contribution. Most of them are 0. Only when you go till 100 percentile or 95, even till 95 percentile, I have 2,277. For 100 percentile, I have some 1,71,870. So see, there is a huge jump. And this is very less expected that I will have this much amount of donation. Now, if I segment it further and if I try to see only for last 5 percentiles, like 95, 96, then you see there is an increment in, and there is a steady increment, steady jump here. So these are quite less expected values, and these are very less in numbers. So even if I treat them and I try to understand, then this manipulation would be on very less number of data. So a better representation to explain you is this. See, most of my data here are concentrated near zero. So this represents my most of the population that I have. Most are concentrated near zero. Most of them haven't donated anything. So if I don't replace them or don't treat them, uh, it won't create a correct representation of my entire population. I'm expected to have some high donation, but that is expected very rarely, or that is quite very hard to come. Those donations, those high amount. So let us take a density plot and understand. So see, there is a spike near zero, but apart from that, very insignificant values towards the end. So in this way, also one thing happens is I'm not able to comprehend my data properly if I have considered all the ranges, the entire range. So what I'm doing is here, I'm segmenting my data and I have figured out that 1,000 is my range. So somebody who has donated more than 1,000, I'm not going to consider that in my distribution. So now if you see that distribution, I'm able to comprehend it much better. That most of them are near zero, then slowly it keeps on decreasing. So this gives you a better comprehending or better understanding of data. So for that reason, you need to treat your outliers. Need to understand that what would be my correct way to treat them, or to delete them from the data, or to replace them with a better value. So hope it is clear now. So let us move to, so this is something that I will be talking about soon, that these are the levels that we have in model development. So firstly, so now we are going through first of the some exploratory things and trying to understand that how should be my data and how if I can treat and understand my exchanging values. So when it comes to real world data, the major two challenges that we have are missing values and outliers. These are the major two problems. So for outliers, I have given you a bit of idea. So let us see what would be there for a missing value. For let's say, uh, so any idea or any suggestion that how we can create a missing value? So large view of this. So Dinesh, is this what you are?
No, actually, I'm talking about PPT.
Okay, okay, fine.
Thank you.
Yeah. So okay. So okay. So actually, I will be going. No issue that I will be going there. So regarding missing values, so one of you said that we can replace it by mean or median. So, but there is also a condition that we need to check. For example, let us say, yeah, proc frequency is one of the equivalent in SAS. So let's say this is my distribution. This is what I have, and let's see what is the mean that I'm getting. So mean of my value is 980, and let's see, very few people have donated somewhere near to 950. My average goes high only because someone has donated very high amount, but if I see my distribution, very less people here have donated uh, 8 980 rupees. So should I be taking mean? So let me consider for median as well. Median is 75. So what I should be taking here? Mean or median?
Median.
Correct.
Medium.
Yeah. So there is a reason to it. So let's say if I have a normal distribution, something like this, or a Gaussian distribution, or most of you who are working in a company, you must be aware of bell curve. So my bell curve something looks like this. Sorry. So in this bell curve, if this is my entire distribution, so I know that most of my distribution is concentrated around my mean value. So this is my mean value, and most of my population is somewhere near to this. So in this case, I can replace it with mean value. But here it was not the case. My distribution was somewhat different to this. So if I go back and so you see here it was not the case. My distribution was skewed to more towards left hand side. So if I consider only from the range of 0 to 1000, it was skewed this towards this side, and most of my population is concentrated somewhere near this, near 0. So in that case, what happens is median becomes my better representation of missing values or for treatment of missing values. So here you need to understand two things. There is something called right skewed and something called left skewed. So right skewed is what happened is if my population is something like this, what we just saw now, it is right skewed. So in this case, most of the population which is near to this maximum range, this is where unknown value should be belonging to, not from the value of something main. My main would be expected to be somewhere here, but most of my population will be here. So median would be a good estimate here as well. Yeah. So that is this was left skewed. Now if I consider the other way around, this would be my right skewed. So this is bent towards my right hand side. So my distribution is more towards right hand side and I'm expected to have most of my values here towards this part. So in that case, even if I take my main would be somewhere here. So I don't need to take it here. Taking a main or taking a median value would be a better representation in this case. So hope it all makes sense now. And also you need to judge according to the. So this was a rough, rough understanding of how we should replace our data or how we should replace some missing values. But when it comes to a data set like we did just now, depending upon the data and depending upon our understanding that what we have comprehended, on basis of that you have to make a judgment then. So for every case it would be quite different. Here we have make some exploration of the data and here we have understood that what should have been a good equivalent or good replacement for our missing values. But the this representation could be different for different data set. So for that you need to judge and explore the data set to have a better understanding.
So will we make a decision based on the standard deviation?
Standard deviation, yeah, that is we can do that, but only when we have a normal distribution, not right skewed, left skewed.
Okay.
It should be a normal, perfectly normal distribution then.
Okay. Also, how do we measure the skew in R?
Skewness for measurement, I'm quite not sure because uh, mainly what happens is when a distribution is not skewed, your mean and median value will be very close to each other. But in case if both are
Okay.
quite set apart with a very large distance, then it means that my distribution is skewed. So that is mainly a
Okay.
judgment. For measurement of skewness, I think there should be uh, a command for that. I need to check on that. But mean value and median value are also a good representation to understand that if my distribution is skewed or not.
Okay. Yeah. Thank you.
So there are few levels. Correct, Akshay. Skewness and kurtosis concept. So we will come to that as well. So Jyoti, distribution, mainly we can use density plot. So like what I did here, it was a density plot. So for density plot, this is the command. So this is there in the previous day R script. You can go through this. Density plot is quite a good estimate to understand that what would be my distribution, or if it is skewed or not, or it is following a normal pattern or not. For normality, we have another test as well. Let me. So there were few tests for that. One was a QQ plot. We will do this in our linear regression and try to understand that why QQ plot is important. Another one was mm, there was a test. Mm, I forgot the name. So now it was Shapiro-Wilk test. So Shapiro will also test the normality, whether my distribution is normally distributed or not. Shapiro will, and there was something, a Kolmogorov-Smirnov test. Yes, Shapiro test is the command. This is the command for checking the normality. So there we also have some hypothesis and null hypothesis. So I think the null hypothesis was that it is not a normal, and so let me check on that. Shapiro test is there. There is also KS test, uh, Kolmogorov-Smirnov test. There is a command for that. So these are the things that we will discuss in our upcoming classes, especially in linear regression. These things will be covered, and to test the normality. So a density plus plot gives you a good estimate, but that won't be sufficient to understand whether it is completely normal or not. This test, Shapiro will test, is a good estimate, but for that there was some constraint. In R, you have to take a sample of 5,000 data, 5,000 rows, and only on that you can make a good estimate. So that was the, I think, constraint with Shapiro. So these are few of the things that we have already done. Number of missing values and non-missing values. So if you remember, I have explained this about sum of is dot na, and here will be my variable. So this will give me sum of all the, or number of all the uh, values which are na. So is.na will return true or false, and whether it is na or not, after that it will sum. So for all the na values that it get, it will make a sum and will give me how many values are missing. So this is a correct representation, or you can say equivalent command in uh, R. For SAS, we have proc frequency. It gives you a list of missing values there down. That these are the number of values that are missing. Mean, max, median, these things were covered. Quantile numbers that we have already covered just now. Standard deviation also, variance also. So skewness and kurtosis, let us explain. So skewness, just have explained that I could have either left skewed or right skewed, and dependingly, I cannot take mean in this case. For these reasons, we have to take median here, and this is called my kurtosis. So a normal distribution will have something like this, and this will be my somewhat like my t distribution or a flat distribution that I call. Most of the things are more or less flat, and this is my high kurtosis, that I get a very high extreme values towards middle values, towards my middle range. So if I'm considering a range somewhere near to my mid or median values, I'm expected to have quite large values. So this is the kurtosis concept.
Ankit, can you just repeat this again?
Okay, so if you see uh, medium, so this is what we normally expect from a data set to be, or Gaussian distribution or complete normal distribution. This is how we expect. So now if say if most of my distribution is like a flat one, and there is a bulge somewhere here and it goes on, so it will be something like my low kurtosis, that I don't see much variation here. High kurtosis would be, it goes behaves like a normal, but towards the missing mid value, it takes a high, or the ranges go up. ranges the value that I see that goes quite high.
So is it like that this can, I mean, for high kurtosis, this will be can give us some seasonality effect. So let's say some kind of any festival is going on. So in that particular period, we can have a high peak due to this high sailing. So in that cases, we can get this high kurtosis.
No, for that reason, what happens is, so what you're saying is a typical example of a time series data set. So, the seasonal effect or a cyclic effect that is there in a time series data. So, but here we, for example, if I'm taking this data of my contribution made by or the donation made by my alumni, so here I don't have any seasonal effect or any particular or any reason for that. So seasonal effect is quite different. That treatment, and when it comes to time series, that entire context would change. But here I am considering only for a certain population. So there is. So this is a quite kind of estimate. Don't take it as a line of or something that is casted on stone that this has to be followed. But a rough estimate this would give that what are the normal or a specific norm to judge my missing value or treat my missing and outlier values. So uh, so here we have impute on the basis of related variable. So for example, let's say discrete. Discrete would be my gender. Uh, no, sorry. That would be my categorical. Sorry. For discrete, um, let's say something like my age. So age here I have taken only as a range from. So it is only a integer value, not the age, month, days like that. Only my integer value is there. So for example, if I have age as missing, so what would be the case to state those ages? So first one it says impute based on the related values. So for example, in my data set, for every specific name, I have a age. Okay, uh, and let's say I have a title associated with every name. For example, I have Mr., Mrs., then Master, Miss. So now let's say a master or someone who has a title of master, he's not expected to be more than a certain age. Let's say 18 or 15. Let us decide a limit. So he's not expected to be more than that. So we can set that limit, and what we can do is for all the titles or all the names which have the title of master, we can filter them out and we can impute or we can calculate the mean for that value. So for all the masters we have got the mean, and on basis of that we will calculate that if they are missing values for master, then what it should be replaced with. So for most of the cases we impute it on the basis of related variables that we have here. And again, what here we have that if I have a missing value, then I treat it as 1, otherwise 0. So what I do is I'm making a categorical impact for the missing values. So what my data set will do is I'm making a flag for it. So a few days back also I was going through a data set where for the account or the what I can say is my the amount that I have as a balance in my bank account. So for some of the values that was NA, many values were 0, and there were some values as well. some non-missing or non-zero values. So what I did there is, for all the NA values that were there, I have replaced it with 0. But at the same time, I have made a dummy variable. That dummy variable was flagged for every missing value and made 0 for non-missing values. So typically in the case of bank account, what would happen is, if I'm getting a NA value in my amount part, then I'm expecting that that person won't be having much of money, or I can expect that he would be having a zero balance, or he must have started recently his account. For that reason, it is coming out to be null, or it could be possible that it is closed account, so there is zero value, or for that reason it is getting null. So these could be my assumptions on basis of which I can say that there won't be any value, because if a bank is maintaining some uh, if the bank is maintaining uh, sorry for that disturbance. So some of you are unmute. um, so in case if bank is having data of all my customers, and it is keeping any value for some reason for some customers, so then uh, I can safely assume that for those accounts the balance is zero. Why? Because a bank won't give missing values or a null value for a customer who has some uh, money in his account. So that would be a complete misinterpretation on the part of bank, and a bank won't be quite likely to do that, to miscalculate the amount of money it has from its customer. So for that reason, it is safe to assume that. But here, as I can see, that a majority part of my values are zero or null values. It is safe, or it is a good practice to make a dummy variable and to replace it with one for all the missing bases that I have. So here, as I said, for continuous variable, and also there were few cases. For example, in gender, there were some missing values. The data which I was working with. So there, what happened is, uh, I had the name of the person, but the gender was missing. Now, if a person has a title of Miss or Mrs., then it is safe to assume that that gender of the person would be a female. And similarly, if a person is having Master or Mister to his name, then it is also good to assume that the person would have a name or gender of male. But in case if both of the things are missing, that also happens, but that was quite rare. So for that, there was a name. Let's say Sunita was a name. So I can expect the Sunita name, the person would be female. Though it would be my assumption, and I don't have any uh, thing or any data in the or any point in my data set to validate my assumption. But from normal perspective, if you think a person with name Sunita will be definitely a female. Hey, so this was the assumption. And also there were some data sets in a hospital or a healthcare where a person whose gender was missing, but uh, she was on maternity ward. She was admitted to a maternity ward. So if a person is admitted to a maternity ward, so it is. So what would be my assumption? Is that a person male or female? So in those cases, it becomes quite obvious. But otherwise, the replacement could be with mean, or in case if I'm having a continuous value, I can replace it with a mean or a median value, or As said earlier, I can make necessary changes or based on my different variables that I have uh, along with my missing variable value. I can impute accordingly and create a dummy variable, or I can replace it according to the situation. So those things that has to be decided with the data set that I'm working with. A few cases I've made some examples to explain you, but it is completely on a judgment. Also, a few days back, I was working on one of the data set that was on Titanic. Titanic dataset also had some of the, and Titanic dataset is available in Kaggle. So I can recommend you to go through the Titanic dataset and to understand that how this dataset work. So I was working with the data and there were lots of missing values. So there comes the challenge that how uh, interpret the missing values, how you judge that, and how you treat them. There it becomes your presence of mind and deep understanding of the data that is required to work. So that is all from me today. So in case if you have any questions, you can ask. Apart, other than that, we are good to wrap up.